Hi guys, welcome once again. I'm very excited to see you in this class again. And I know that's the same way you're also excited to be in this class. Let me ask you one question. What did we study in our previous lesson? You are right. We discussed something about surds. Surds spelled S-U-R-D-S. Surds. That's good. You remember that in that lesson, we talked about perfect squares. And then we said perfect squares are numbers that when found under the square root sign can give us whole numbers. So for instance, we have the square root of 4 being 2, the square root of 9 being 3, and so on. Very good. And again, you remember that we learned how to simplify complex sets. We look at the steps involved in simplifying complex sets. I know you remember that one as well. That's very good. What about today's lesson? So in today's lesson, we are still going to talk about sets, but in this particular instance, we are going to talk about sets involving addition and subtraction, or the addition and subtraction of sets. But can you solve simple addition and subtraction? Oh, I know that's very simple and that's easy for you. So let's see. Let's try or test ourselves. 2 plus 2, and the answer will be, yeah, right, 4. That's easy. But the question here again is, what if you are given sets and then you are asked to add or subtract them? So for instance, the one on the board, like square root of 2 minus 3 square root of 2. If you are given an expression of this form, how do you solve it? You might think that this is quite complex as compared to 2 plus 2, right? But there's no need to fret. It's very simple. All you need to do is to follow me throughout this lesson and you see how simple it is. So if you are asked to give or solve addition or subtraction of sets, how is it mostly represented? That's how you see it on the board. Square root of 2 minus 3 square root of 2. And then in the particular example that we have on the board, it is minus, but you can also have another question that's giving you as an addition. So for instance, if you change the sign, you have plus, like you see on the board now. Now the real question is, how do we solve questions like this? So let's first go through the methods that we can use to solve questions like that. So we have an example of the form a square root of 2 plus b square root of 2. However, students, kindly note that the only time you can add or subtract sets is if the square root or the numbers under the square root sign are the same. Again, kindly note that you can only add or subtract sets if the numbers under the square root sign are the same. So for instance, the one we have on the board, we have square root of 2 and then square root of 2. They are the same, so we can add. What if the numbers are different? So for instance, like the one we have on the board like that, square root of 2 and square root of 5. Can we add or subtract something like this? No, you can't add an expression like that. So you can only add them or subtract them if the numbers under the square root sign are the same. So for the purposes of what we are going to discuss now, we would let the numbers be the same. So because the numbers under the square root sign are the same, just like we said, we can add or subtract. Now, if you look at the ones that we have on the board, for instance, the numbers under the square root sign are the same, so we can add them, right? But how is it done? Your focus should be on the numbers outside the square root. Again, your focus should be on the numbers outside the square root. So we isolate the numbers outside the square root sign, and depending on the sign in the question, whether it's addition or subtraction, we add or subtract those isolated numbers. Then after that, we just keep one of the numbers under the square root sign. We just keep one of them because they are the same. So what do? Just like we said, the first number outside the square root sign, we bring it, then another number outside the square root sign, we also bring it and then add or subtract them. Then we keep, out of the two numbers under the square root sign, we just keep one of them. So you see, it's not something that's so complex like you might think. So let's try with the example on the board. So since A and B are numbers outside the square root signs, then we bring them together and either add or subtract them. So in this particular question, it's addition, so we add them. So we are going to have in one bracket A plus B. Then we said that after that, we just keep one of the numbers under the square root sign. So square root of 2, we just keep one of them. If you're able to follow these simple steps, then you can actually add or subtract sets so easily or simply. One very important thing you should also note is that you should be very careful with the addition and subtraction signs. So you should be very careful and check if it is either addition or subtraction before you continue with your work. So let's take a look at a real example of addition or subtraction of sets. The question on the board is simplify. So simplify the expression 4 square root of 3 minus square root of 3. Again, simplify 4 square root of 3 minus square root of 3. Now, if you see something, or if you see a term that is expressed as the one you see on the board, square root of 3, without any number in front, you always must assume there is 1 outside that square root sign. Again, you should always assume that there is 1 outside the square root sign if there is no number there. So for instance, square root of 3, you know you have 1 there, just like I've expressed on the board. And again, you remember that we said if you want to add or subtract sets, we look at the numbers in front of the square root sign, the first and the second term, then we isolate them and then add or subtract depending on the question. So in this particular question, the number in front in the first term is 4, right? Okay, then the number of the other term outside the square root sign is 1. So what do? We add or subtract them, right? In this particular question, you can see it is subtraction. So meaning that we subtract 4 and then 1. So we are going to end up having 4 minus 1. So let's express that on the board. So we are going to have in one bracket 4 minus 1. Then just like you remember in the previous lesson, or in this particular lesson, we said that you will keep one of the sets, which is the square root of 3. So we write square root of 3, just like you can see. So now we can subtract. So we are going to have 4 minus 1, and the answer will be, the answer will be 3. So our answer is going to be 3 square root of 3. Now that we are done with the subtraction, so can we continue? So you see, the question says simplify, and the answer that we already have is already simplified. So we leave our answer like that. So 3 square root of 3 becomes our final answer. Now let's take a look at another question. So the other question says simplify the said square root of 50 minus square root of 32. Again, simplify the said square root of 50 minus square root of 32. You remember in the previous lesson, we said that when you have complex sets like you see on the board, you need to simplify them. So that is exactly what we are going to do first before adding or subtracting the set. And you know that in simplifying complex sets, we first find a number which is a perfect square multiplied by another number that will give us the number under the square root sign. So you think about a number that is a perfect square multiplied by another number that will give you the number under the square root sign, which with that number being that complex or of that complex form. So for instance, we have square root of 50, which is a complex number, of course. Then in simplifying it, we look for a perfect square number, 25, which we multiply by another number, which is 2, to give us 50. So we know 25 multiplied by 2 will give us 50. And note that 25 is a perfect square. So you should always know that the two numbers, one of them should be a perfect square. So let's try with the next number, which is square root of 32. That one too, we think about it and then we can find 16 being the perfect square. And when we multiply 16 by 2, the answer we are going to have is 32. So with the two expressions that we have already, we'll just put them back in the original expression. So we are going to have square root of 25 multiplied by 2 minus square root of 16 multiplied by 2. Again, in the previous lesson, we said that after getting an expression like this, we need to separate them. So we are going to separate them. So we are going to have square root of 25 multiplied by square root of 2 minus square root of 16 multiplied by square root of 2. This makes the working very simple. Now, you know square root of 25, or 25 is a perfect square. So square root of 25, and the answer is going to give us a whole number, which is 5. Then we just multiply by its square root of 2, because square root of 2 is not a perfect square, or 2 is not a perfect square. Then to the other term in the expression, so minus, we bring our minus, then you know again 16 is a perfect square. So square root of 16 is also going to give us a whole number, which is, yes, you remember, is 4. So let's write that. Again, we know 2 is not a perfect square, so we have square root of 2 and then we keep it like that. So we multiply it by 4 and we get 4 square root of 2. Now, you see that just like in the previous example, we have a subtraction of surd expression. Now you can also see that we have square root of 2, square root of 2 in those two terms. So it means that we can, yes, we can add or subtract them because they are the same. And again, you know that we said the numbers in front of the square root sign, we are going to isolate them and subtract them because the question is a subtraction question. So 5 and 4, which are both outside their respective square root signs, we are going to isolate them. So we are going to have 5 minus 4, then we keep the irrational number, which is the surd square root of 2. So what will be the answer for 5 minus 4? Yes, the answer will be 1. So we are going to have 1 square root of 2. But in this class, you remember that we said that always when there is 1 in front of the square root sign, it is much easier or much simpler to express it as square root of 2 or square root of whatever number is under the square root sign. So in this particular instance, we are going to have square root of 2. So in today's class, what have we discussed? We said that in order to add or subtract sets, first you need to make sure that the numbers outside the square root signs, you would isolate them and either add or subtract, depending on the question, of course. whether it is positive or it is negative. Then after that, the two sets that are there, you realize if the numbers are the same, we just keep one of them, just like we discussed in this lesson. And then we also said that if the numbers under the square root sign are the same, we can add. If they are not the same, we do not add them. So if you're able to follow the steps that we've discussed in this particular lesson, you will be able to solve questions like this. I am so excited to have been with you in this class, and I wish to meet you soon in the next class. Bye.